Now in the problem, we have given a values. We are given an equations which along with lambda and mu. Now we need to find out whether the equations are having a no solutions or unique solutions or infinite number of solutions. Now first of all, write down the above equations in terms of matrix form. We can write in terms of matrix form as 1 1 1 1 2 3 1 2 lambda multiply with x y and z is equals to 6 10 and mu. By writing this is in terms of ax is equals to b. Now writing an argument matrix, you can write an argument matrix equals to 1 1 1 6 1 2 3 10 1 2 lambda mu. Now from here we need to find out the rank of a matrix. Rank of a matrix as well as rank of argument matrix to find a unique solution or number of solutions or no solutions. Now here we need to do row and row transformations, elementary row operations. We can write R2 implies R2 minus R1 and R3 implies R3 minus R1. Then we can have an equation of 1 1 1 6 0 1 2 4 0 1 lambda minus 1 and mu minus 6. Now R3 implies R3 minus R2 is equal to 1 1 1 6 0 1 2 4 and 0 0 lambda minus 3 and mu minus 10. This is a matrix, argument matrix. Now to have no solutions, rank of matrix A not equals to rank of argument matrix. Now to have that one, therefore it is lambda minus 3 will be is equals to 0. Therefore lambda is equals to 3 and mu minus 10 is not equals to 0. This is for no solution. For unique solution, rank of matrix A must be equals to rank of matrix B. Therefore lambda minus 3 must be not equals to 0 and mu minus 10 may be 0 or mu minus 10 must not equals to 0. For unique solutions, rank of A is equals to rank of B is equals to number of unknowns which is nothing but 3. To have a infinite solutions, rank of A must be equal to rank of AB. Argument matrix must be less than number of unknowns. Therefore, lambda minus 3 must be equal to 0, which implies lambda is equal to 3, and mu minus 10 must be equal to 0, which implies mu is equal to 10. This is for infinite number of solutions. For unique number of solutions, lambda minus 3 must be not equal to 0, and mu minus 10 it may be 0 or mu minus 10 not equal to 0. For having the rank of A equals to rank of B equals to number of unknowns. For no solutions, lambda is equals to 3 and mu minus 10 must be not equals to 10. The matrix A 1 2 1 0 minus 2 4 3 0 1 0 2 minus 8 by using echelon form. To find out the solutions, here the matrix is a 3 by 4 matrix. Now we will do the elementary transformation of the matrix by considering the matrix A. Now here the matrix A is equals to 1 2 1 0 minus 2 4 3 0 1 0 2 minus 8. Here this matrix is a 3 by 4 matrix. Now if you observe carefully, now the row 2 is minus 2. Now if we are by adding 2 R1, this value will become as a 0. Now you can write R2 implies R2 plus 2R1. At the same time, we can do one more operation. Here is row 3 is 1. You can make it as 0 by considering R3 minus R1. Now you can write as R3 implies R3 minus R1. Then the matrix A is become as A is equals to, the row 1 will be as it is 1 2 1 0. Now here by adding to R1, this value is 0, 4 plus 2 into 2 which is 8, 3 plus 2 5, 0 plus 0 is 0. Now for R3 implies R3 minus R1, then this value is 0, minus 2, 1 and minus 8. This is the matrix. Now here if we observe carefully, this in the R3, if we multiply with, now by considering this minus 2 can be made to 0 by adding R2. At the same time R3 will be multiplied with 4. If we multiply with 4, this will become minus 8. If you observe this minus 2 is there, the minus 2 can be multiplied with 4, then automatically in the row 3. In row 3, minus 2 can be multiplied with 4, then automatically become minus 8. Then this element will become as a 0. By considering R3 implies 4R3 plus R2, then matrix A will become 1 2 1 0 0 8 5 0 and 0 0 9 minus 32. From hereafter there is no possibility to make this row 3 9. The third element will not be, because there is no possibility of the to become 9 to 0. Then the rank of the matrix is equals to 3. Now first of all, by solving the equations you can obtain the value of x is equals to 9 minus 2y minus z by 10. Y equals to minus 22 minus x plus z by 10, and z is equals to 22 plus 2x minus 3y by 10. In Jacobi iteration method, in first approximation, in first iteration, let x equals to 0, y equals to 0, and z equals to 0, and we will find out the values of x in the first iteration, y and z in the first iterations. Now by using this x in the first iteration, y in the first iteration, and z in the first iteration is equals to 9 minus 0 minus 0 by 10, which is equals to 0.9 minus 22 minus 0 plus 0 by 10 equals to minus 2.2. Z in the first iteration is 22 plus 0 minus 0 by 10 equals to 2.2. Therefore, x in the first iteration is equals to 0.9, y in the first iteration is equals to minus 2.2, z in the first iteration is equals to 2.2. Now again we'll go for second iteration. For second iteration we will consider these values, and again in the second iteration, y in the second iteration and z in the second iteration equals to 9 minus 2 into y is minus 2.2 minus 2.2 by 10. You can obtain this value is 1.02. Here minus 22 minus 0.9 plus 2.2 by 10. Its value is minus 2.07. 22 plus 2 into 0.9 minus 3 into minus 2.2 by 10 equals to 3.04. X in the second iteration is 2, x in the second iteration is 1.02, y in the second iteration is minus 2.07, and z in the second iteration is 3.04. Again we'll find out x, y, z for third iteration by substituting the values here. 9 minus 2 into minus 2.07 minus 3.04 by 10.010 and y minus 22 minus 1.12 plus 3.04 by 10. If you substitute the values, you can obtain minus 2.008 and z is equals to 22 plus 2 into x is 1.12 minus 3 into y is minus 2.07 by 10. You can get 3.045. Therefore, these are the values for third iteration. See the second iteration. In the second iteration, we got the value of x. In the second iteration is 1.12. Y in the second iteration is minus 2.07. Z in the second iteration is 3.04. We are substituting these three values in for third iteration. This is for third iteration. Now again we are doing the same thing for fourth iteration by considering the values of x of 3 for the third iteration, which is 1.010, and y of 3 is minus 2.008 and z of 3 is equal to 3.045. Now we will go for fourth iteration. Now x of 4 is equals to 9 minus 2 into minus 2.008 minus 3.045 divided by 10. Can obtain the value of x of 4 is equals to 0.9971. Similarly, y of 4 is minus 22 minus 1.01 plus 3.045 by 10 is equals to minus 1.9965. Z 22 plus 2 into 1.01 minus 3 into minus 2.008 divided by 10. You can get 3.0044. The values of x for fourth iteration is 0.9971. Y for fourth iteration is minus 1.9965. Z for fourth iteration is 3.0044. Now, by using these three values, we will do for fifth iteration. In fourth iteration, Z in fourth iteration, X in fourth iteration. And if we are finding the values, now we can obtain 9 minus 2 into minus 1.9965 minus 3.0044 divided by 10. This is for x. For y, minus 2 to 2 minus 0.9971 plus 3.0044 divided by 10. For z, 22 plus 2 into 0.9971 minus 3 into y is minus 1.9965 divided by 10. By solving these three, we can obtain the values for fifth iteration. X in the fifth iteration is 0.9988. Y is minus 1.9992. Z is of 2.99 83. Fifth iteration value is 0.9988. Y in the fifth iteration is minus 1.4992, and Z in the fifth iteration is 2.9983. Here we will find out the values of X in sixth iteration, Y in sixth iteration, and Z in sixth iteration. By observing the values, if the difference is, if we got the same value, the corresponding answers of X is equals to 5, Z X is equals to 1, Y equals to -2, Z equals to 3. 0.9999, where Y is equals to -1.9999, and Z is equals to 2.9999. By reducing the matrix 2, 3, -1, -1, 1, -1, -2, -4, 3, 1, 3, -2, 6, 3, 0, -7 into normal form, find its rank. In normal form, we can reduce the 4 by 4 matrix into a finite number of elementary rows and columns transformation with an identity matrix and 0, 0, 0, 0, 0 is called normal form. This is also called canonical form. R2 double implies R1, interchanging R1 and R2. Now we can have a matrix 1, -1, -2, -4, 2, 3, -1, -1, 3, 1, 3, -2, and at last 6, 3, 0, -7. R2 implies R2 minus 2R1. Here this 2 term will be cancelled. Now for R3, R3 minus 3R1. And for R4, R4 implies R4 minus 6R1. Now the matrix A will become, row 1 will be as it is, 1, -1, -2, -4. In second row this value will be 0. Here 3 minus of -2 is 5, 3, 7, 0, 4, 9, 10, 0, 9, 12, 17. Now for this matrix of C2 implies C2 plus C1, C3 implies C3 plus 2C1, and C4 implies C4 plus 4C1. A is equals to 1, 0, 0, 0, 0, 5, 4, 9, 0, 3, 9, 12, 0, 7, 10, 17. R2 tends to R2 minus R3. Then A will be 1, 0, 0, 0, 0, 1, -6, -3, 0, 4, 9, 10 remaining elements will be as it is 0, 9, 12, 17. R3 implies R3 minus 4 R2 and R4 implies R4 minus 9 R2. Then matrix A will become A is equals to 1, 0, 0, 0. Second row will be as it is 0, 1, minus 6, minus 3. Third row will be 0, 0, 0, 33, 22. And last row is 0, 0, 66 and 44. C3 implies C3 plus 6C2 and C4 implies C4 plus 3C2. A is equals to 1, 0, 0, 0, 0, 0, 0, 0, 0, 33, 66, 0, 0, 22, 44. Now R3 implies 3 by 11, R4 implies R4 by 11. The matrix A will become A is equals to 1, 0, 0, 0, 0, 1, 0, 0, 0, 0. Here it is 3, 2, 0, 0, 6, 4. C3 implies C3 minus C2 is equals to 1, 0, 0, 0. Now R4 implies R4 minus 2R3. Yes. A will be 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 2, 0, 0, 0, 0. Now C4 implies C4 minus 2C3. Now A will be 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0. This is 0, 0, 0, 0. If you observe carefully, this is an identity matrix, 3 by 3 identity matrix. Therefore, the rank of the matrix is equals to 3. To find inverse of matrix, first of all, we'll consider a matrix A which is equals to an identity matrix multiplied with A. Now by doing elementary row transformation, we'll find out we'll obtain an identity matrix in A corresponding the identity matrix will become an inverse matrix. Let A equals to identity matrix of 3 by 3 matrix, write it as multiply with A. The A matrix A we are written as 1, 3, 3, 1, 4, 3, 1, 3, 4, which is equals to an identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. multiply with A. Now by doing R2, R2 implies R2 minus R1, and R3 implies R3 minus R1. Now the matrix, the left side A matrix will become, row 1 will be as it is 1 3 3. Here is 0 because 1 minus 1 is 0, and 4, R2 minus R1, 4 minus 3 is 1, and 3 minus 3 is 0. Similarly, third row will be 0 0 and 1. Coming to the right side identity matrix, for the identity matrix also we will do the same row transformations. Row 1 will be as it is, second row will be -1 1 0, third row is -1 0 1, multiply with A. R1 plus R1 minus 3 R2, then R1 is, first element is 1, minus 0 is 1 only, 3 minus 3 will be 0, 3 minus 0 will be 3. Here is second row will be as it is. Now on the right side matrix also you have to do the same row transformations. R1 minus 3 R2. Here second row first element is -1. -1 into 3 is +3. 4 minus 3 0 -1 1 0 -1 0 1, multiply with A. Now the aim is to do the first left side matrix. Here left side matrix, row 1 third element must be 0. To make it to 0 we will have to do R1 implies R1 minus 3 R3. Then the first left side matrix first row third element will become 0. Now by doing here you can obtain, it is 1 0 0 0 1 0 0 0 1, which is an identity matrix. Now corresponding on the right side the matrix will be 7 minus 3 minus 3. Here is -1 1 0 -1 0 1. This matrix is called inverse matrix. Why? Because identity matrix I is equals to A inverse of A. Therefore, we have obtained the inverse matrix. A inverse is equals to 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. This is the inverse matrix by using Gauss-Jordan method. By solving the equations, we can obtain the value of from equation 1 x is equals to 17 minus y plus 2z by 20. Y is equals to minus 18 minus 3x plus z by 20, and z equals to 25 minus 2x plus 3y by 20. Now in the first approximation, we will consider the first approximation in Jacobi iteration method. We will consider let x equals to 0, y equals to 0, and z equals to 0. Therefore, x in first iteration is equals to 17 minus y is 0 plus z is 0 divided by 20 equals to 0.85. Y in first iteration is equals to minus 18 minus 3x, 3 into x is 0 plus z is 0 divided by 20 is equals to minus 0.9, and z in the first iteration is equals to 25 minus 0 plus 0 divided by 20 equals to 1.25. The values in the first iteration is x of 1 is equals to 0.85, y of 1 is minus 0.9, and z of 1 first iteration, first approximation 1.25. Now in the second approximation, we will use the values of x in the first iteration and x. Now by substituting the values of x in the first iteration, which is 0.85, y in the first iteration, which is minus 0.9, and z in the first iteration, which is 1.25. For second approximation, x of 2 is equals to 17 minus y plus 2z by 20, which is gives 17 minus of minus 0.9 plus 2 into 1.25 by 20, which is 1.02, and y of second iteration is minus 18 minus 3x plus z by 20. Here also the value of x in the the first iteration we will substitute, and z in the first iteration we will substitute to obtain the y in the second iteration. Now the corresponding value is minus 0.965. Similarly, z in the second iteration is equals to 25 minus 2x plus 3y by 20, which implies we will obtain the value of z in the second iteration is 1.03. Now by writing the terms x in the second iteration, y in the second iteration, and z in the third iteration, we can use these three values for to find out the value of in the third iteration. In x, the third iteration is 17 minus y is of minus 0.965 plus 2 into 1.03 divided by 20. We can obtain the value of x in the third iteration is 1.0012. Now to find out y in the third iteration is equals to minus 18 minus 3x plus z by 20, which is equals to minus 18 minus 3 into x value is 1.02 plus z is 1.03 divided by 20. You can find the value is equals to minus 1.0015 and z in the third iteration is equals to 25 minus 2x plus 3y by 20 equals to 25 minus 2 into x is 1.02 plus 3 into minus 0.965 divided by 20. We can find the value z in the third iteration is 1.0032. Now these are the values of x in the third iteration, which is 1.0012, and y in the third iteration is minus 1.0015, and z the third iteration is 1.0032. Now by using these three values to obtain again for fourth iteration, x in the fourth iteration is equals to 17 minus y plus 2z by 20 equals to 17 minus of y is minus 1.0015 plus 2 into z is 1.0032 divided by 20 equals to, you can obtain the value of x. The fourth iteration is 1.0004. This is the value of x in the fourth iteration. Similarly, you need to find out the value of y in the fourth iteration. Y in the fourth iteration is equals to minus 18 minus 3x plus z by 20 equals to minus 18 minus 3 into y is minus 0.0 minus 1.0015 plus 1.0032 divided by 20. You can find the value of y is minus 1.402. Z in the fourth iteration is equals to Z in the fourth iteration is equals to 25 minus 2x plus 3y by 20, which is equals to 25 minus 2 into x is 1.0004 plus 3 into y is minus 1.402 divided by 20. We can obtain this value is 0.9996. These are the values of x, y, z in the fourth iteration. Y in the fourth iteration is minus 1.002402 and z in the fourth iteration is 0.9996. Now again for fifth iteration we will substitute these three values in the fifth iteration. Therefore x of x in the fifth iteration is 17 minus y plus 2z by 20, which equals to 17 minus y is of minus 1.00402 plus 2 into 0.9996 divided by 20. You can find this value is equals to 0.99. No. Similarly, if I note the y in the fifth iteration is minus 18 minus 3x plus z by 20 is equals to minus 18 minus 3 into x is x value is 1.304 plus z is 0.9996 divided by 20. You can find this value is 1 point minus 1.07 and z for fifth iteration is equals to 25 minus 2x plus 3y by 20 equals to 25 minus 2 into 1.0004 plus 3 into minus 1.402 divided by 20 equals to 0.9996. X of in the fifth iteration is 0.49. Y in the fourth iteration is minus 1.407 and z in the fourth iteration is 0.9996. Now again we'll go for sixth iteration. Now again if you are finding the sixth iteration by substituting the values of in the fifth iteration, we will find out x in the sixth iteration by using the formulas 17 minus y plus 2z by 20 by considering these values you can find 17 minus of minus 1 point plus 2 into 0.96 divided by 20. It will give us a value of 0. And y in the sixth iteration is minus 18 minus 3x plus 2z. Sorry. Z by 20 equals to minus 18 minus 3 into x is 0.999 plus z is 0.996 by 20 equals to minus 0.9999 and z in the sixth iteration is equals to 25 minus 2x plus 3y by 20 equals to 25 minus 3 into x is 0.9999 plus 3 into y is minus 1.407 divided by 20. You can find the value of z in the sixth inversion is 0.9999. The values are x in the sixth inversion 0.9999, y in the sixth is minus 0.9999, z in the sixth is 0.9999. Now from these values, again you need to find out the value of for seventh iteration. Then the values are similarly by using the same these values you can substitute in the above formula and you can get the value. So the seventh iteration is 0.9999, y in the seventh iteration is minus 1.503, z in the seventh iteration is 0.9999. You can conclude the values of x equals to 1, y equals to minus 1, z is equals to 1. Solve the equations by Gauss-Seidel iteration method. Now in this method, the first condition is, from the first equation, the condition we can write it as from the first equation the magnitude of 10 is greater than or equals to y magnitude plus z magnitude. This is from equation 1. Similarly, second magnitude is for y must be greater than the magnitude of x. X coefficient is 1 and the z coefficient is 1. This is from equation 2. Magnitude of z coefficient is 10 is greater than or equals to x coefficient is 2 and the y coefficient is 2. This is from equation 3. Now from equation 1 we can write it as, from equation 1 we can find the value of x is equals to 12 minus y minus z by 10. This is equation number 4. Because this is the first equation, this is the first equation, this is the second equation, and here is the third equation. Now this is equation number 4. Similarly, we'll find out y is equals to 13 minus 2x minus z by 10. This is equation number 2. Sorry, this is equation number 5. Coming to z coefficient, z is equals to 14 minus 2x minus 2y by 10. This is equation number 6. In the first approximation, let y is equals to 0 and z is also equals to 0 in equation 4. Now we can able to find out the value of x in the first iteration is equals to 12 minus 0 minus 0 by 10, which is equals to 1.2. Now in the first iteration, let x in the first iteration is 1.2 and z equals to 0. So substitute in equation 5, then you are able to find out the value of y in first iteration. Y in first iteration is equals to 13 minus 2 into x in the first iteration is 1.2 by 0, z divided by 10, which will gives 1.06. This is the y in the first iteration. Now we have x in the first iteration and y in the first iteration. Let x in the first iteration is 1.2 and y in the first iteration is 1.06. Substituting in z in the first iteration is equals to 14 minus 2x, 2 into 1.2 minus 2y, 2 into 1.06 divided by 10 will gives the value of 0.948. Therefore, now we can able to find out the values of x in the first iteration is 1.2, y in the first iteration is 1.06 and z in the first iteration, which is 0.948. Now we'll find out for second iteration. The second approximation, x of 2 is equals to 12 minus y of first iteration minus z of first iteration by 10, which is equals to 12 minus 1.06 minus 0.948 divided by 10, which is equals to 0.9992. Y of second iteration is 13 minus 2x, which is 0.9992 minus 0.948. Here this 0.992 is from the second iteration, whereas 0.948 is z from the first iteration divided by 10. You can obtain the value of 1.0053. This is y of second iteration. Now z of second iteration is equals to 14 minus 2 x of second iteration minus 2 y of second iteration by 10. By substituting the values, 14 minus 2 into x of second iteration is 0.9992 minus 2 into y of second iteration 1.0053 by 10. You can obtain the value is equals to 0.9991. This is z of second iteration. Now in third approximation, now the values are x of second approximation is 0.9992, y of second approximation is 1.0053, and z of second approximation is 0.9991. Now for third approximation, again we will find out x of third approximation is 12 minus y of second approximation minus z of second approximation by 10 equals to 12 minus 1.0053 minus 0.9991 by 10 equals to 0.9995. Y of third approximation is 13 minus 2 x of third approximation minus z of second approximation divided by 10 equals to 13 minus 2 into 0.9995 minus 0.9991 divided by 10 equals to 1.0001. Z of third approximation is equals to 14 minus 2 into x third approximation minus y 2 into y of third approximation divided by 10 equals to 14 minus 2 into 0.195 minus 2 into 1.0001 divided by 10 equals to 1. Now we can write the values of third approximation values is of third approximation is equals to 0.9995, where y is equals to y of third approximation is equals to 1.0001, z of third approximation is equals to 1. Now in fourth approximation, x of fourth approximation is equals to 12 minus y of third approximation minus z of third approximation divided by 10 equals to 12 minus 1.301 minus 1 divided by 10, which is 0.249. Y of fourth approximation is equals to 13 minus 2 into x of z of third approximation divided by 10 equals to 13 minus 2 into 0. Minus 1 divided by 10 equals to 1. Z of fourth approximation is equals to 14 minus 2 into x of fourth approximation minus 2 into y of fourth approximation divided by 10. You can have 14 minus 2 into 0.19 minus 2 into 1 by 10 equals to 1. Therefore, the values are x of fourth approximation is equals to 0.49, y of fourth approximation is equals to 1, z of fourth approximation is 1. Fifth approximation, x of fifth approximation is equals to 12 minus y of fourth approximation minus z of fourth approximation by 10 equals to 12 minus 1 minus 1 by 10 equals to 1. Y of fifth approximation is equals to 13 minus 2 into x of fifth approximation minus z of fourth approximation divided by 10 equals to 13 minus 2 minus 1 by 10, which is equals to 1. Z of fifth approximation is equals to 14 minus 2 into x of fifth approximation minus 2 into y of fifth approximation divided by 10 equals to 14 minus 2 by 10 equals to 1. Therefore, x of fifth approximation is equals to 1, y of fifth approximation is equals to 1, z of fifth approximation is equals to 1. In sixth approximation, x of 6 is equals to 12 minus x of fifth approximation minus z of fifth approximation divided by 10 equals to 12 minus 1 by 10 is equals to 1. Y of sixth approximation is equals to 13 minus 2 into x of sixth approximation minus z of fifth approximation by 10 equals to 13 minus 2 minus 1 by 10 is equals to 1. Z of sixth approximation is equals to 14 minus 2 into sixth approximation minus 2 into y of sixth approximation divided by 10 implies 14 minus 2 divided by 10 equals to 1. Now you can observe the values clearly. The values in fifth approximation and sixth approximation are equal. X of fifth approximation is equals to x of sixth approximation. y of fifth approximation is equals to y of sixth approximation. Z of fifth approximation is equals to z of sixth approximation. Therefore, x is equals to 1, y equals to 1, and z is equals to 1. Now in this problem, first of all, we need to write an argument matrix. The given from this argument matrix is 1, 2, 3, 3, 4, 4, 7, 10, 12. Here is 0, 0, 0. This is the matrix A, this one is matrix B. This is argument matrix. Now for this matrix, we need to do the elementary row transformations, and now by doing elementary row transformation, R2 implies R2 minus 3R1 and R3 implies R3 minus 7R1. The matrix will be row 1 will be as it is. Here is 0, 4 minus 6 is minus 2, 4 minus 9 is minus 5, 0, 7 minus 7 is 0, 10 minus 14 is minus 4, 12 minus 21 is minus 9, here is 0. This is matrix, argument matrix. Now in this matrix, you can do R3 implies R3 minus 2R1. Then this matrix will become 1, 2, 3, 0, 0, minus 2, minus 5, 0, here is 0, here is 4 plus 4 is 0, minus 9 plus 10 is 1, here is 0. Now, by observing this matrix, here first row indicates x plus 2y plus 3z is equals to 0. Second row indicates minus 2y minus 5z equals to 0. And third row indicates z equals to 0. Now, if z equals to 0, if we substitute in the second equation, then the value of y is equals to 0. Why? Because minus 2y equals to 0, then y equals to 0. If we substitute yz in the first equation, the value of x is equals to 0. Then the values of x, y and z are x equals to y equals to z equals to 0. All the equations are homogeneous equations. Then the trivial solution is x equals to y equals to z equals to 0. For more videos like matrix inverse, matrix multiplication, matrix determinant, and how to solve equations, you can follow the channel and subscribe. In the given question, the question is, you are having three equations: x plus y plus z equals to 4, 2x plus 5y minus 2z equals to 3, and x plus 7y minus 7z equals to 5. We need to show that the equations are not consistent. Not consistent means the rank of the matrix A is not equal to the rank of the matrix augmented matrix, which is now combining matrix A and B. Now, first of all, you will write these equations in terms of matrix form. The matrix form will be, if I write in terms of matrix form, here you can consider is 1, 1, 1, 2, 5, minus 2, 1, 7, minus 7, multiply with x, y and z equals to 4, 3 and 5. Here, which is ax is equals to b. Now we can write an argument matrix which is nothing but equals to 1, 1, 1, 4, 2, 5, minus 2, 3, 1, 7, minus 7 and 5. We need to find the rank of the matrix of A as well as argument matrix. So to find out the rank, now by doing row transformation, column transformation, now R2 implies R2 minus 2R1 and R3 implies R3 minus R1. By a row transformation, we are able to find out the values of new matrix. New argument matrix is row 1 will be as it is, row 2 will be, here is 0, 5 minus 2 is 3, minus 2 minus 2 is minus 4, 3 minus of 8 is minus 5, here is 0, 6, minus 8 and 1. Again we will do a for R3 implies R3 minus 2 R2. The matrix will become, row 1 will be as it is, 1, 1, 1, 4. Row 2 will be same, 0, 3, minus 4, minus 5, and row 3 will be 0, 0, 0, 11. Now if you observe carefully, the argument matrix, here the rank of the argument matrix B is 3, whereas the rank of matrix A is 2. Therefore, rank of AB is not equal to rank of A. Therefore, it is not a consistent. Thank you for watching. Please like, share and subscribe If you like,